Hello students, in the last session we have discussed about the D flip-flops. In this session I am going to explain about the JK flip-flop. In the JK flip-flop means that one JK flip-flop is a refinement of the flip-flops. In that intermediate condition of the RS flip-flop, define the JK type. Inputs J and K are behaves like a inputs of S and R, set and reset flip flop respectively. Means in the SR flip flop, we are going to study about the SR flip flop. I want to express that one. S is for a set and R is for a reset. That is a definition of that one. Inputs J and K are called as a control input. Means J and K can be called it as J and K can be called it as control inputs. Control inputs. Right. Because of they determine what flip-flop does when the positive clock edge arrives. JK flip-flop can be obtained by the augmenting the clock clocked RS flip-flop with the two AND gates and can we take it and can be expressed like that one. I'm going to just draw the circuit of this one. Can we express? This is the symbol of the using the AND gate. Two AND gate can be used. Yes, this is the S and R flip flops. Q and Q bar are the output. This is a SR flip flop will come. Then can be apply the input J and K. This is converted here. Yes, then I'm going to draw this one. Yes, this can be I'm going to connect that one. JK is a clock. This one is a clock. In the SR flip flop, clock can be taken. This is the symbol of the JK flip flop can be expressed. Yes, and I'm going to explain about this JK flip flops. JK flip flop. I'm going to explain about this circuit in this way. Can be expressed in this JK flip flop. Case 1 and case 2 I am going to express by the JK flip flop. If the first one, this is a flip flop for that one, I am going to express this J equals to 0. Here the circuit it is there. Yes, this is the two AND gates you can use. S and R, Q and Q bar can be used. Yes, this is a circuit. I am going to express this one in this express J equals to 0, K equals to 0. Just I am going to take this. This is the circuit of that one. This is the circuit. I am just expressing this one. This is in the circuit. I'm going to express this one. Yes. Uh, yes. Yes, this is the way can be expressed it in this equation for that one. First condition of that one, truth table, J and the K is here. J and the K is here. chain the K. This is a chain K. 0 0 and 1 1. 0 1 0 1. This is the condition. I'm going to present state of JK. I don't know that one. Whether it is a 0 or a 1, 0 or a 1, 0 1 0 1 can be used. Whether it is a 0 or 1, X means 0 or 1. Next state I am going to express. Next state can be expressed. What it comes? Let us take this one is J equals to 0 and the K equals to 0. J equals to 0 and the K equals to 0. The next stage is Qn plus 1. This is a Qn will come, Qn bar will come. The next state is Qn plus 1. Can we take it? This is a 0 and K it is a 0. This is a condition it is there. Yes. Now I am going to state about this one in this. Using this clock pulse, I am going to take that one. This is a 0. In the SR flip-flop can be used. It is a 1. 1 will be the, here will come that one in the SR flip-flop. Yes, the 1 will come for that one. Yes, in the SR flip-flop. This is in this condition, I am going to take 1 and Qn bar whole bar equals to 1 bar plus Qn bar equals to Qn. Yes, in one more condition, Qn plus 1 whole bar equals to 1 into Qn bar whole bar equals to what it comes. Once is a 0, will Qn bar will come. There is no change condition. There is no change condition can be expressed. Can be expressed in the no change condition. Correct. Next I am going to express it. It is a no change conditions. Yes, in the next state I am going to express it in this way. It is Qn plus 1 equals to J equals to what else it is? Yep. In the next state of that one can be expressed J equals to 0 and K equals to 1. I am going to express these equations in this. Qn plus 1 equals to J equals to 0 and K equals to 1. Can be used in SR flip-flop can be used. That kind of things will come for that one. 1 into Qn bar. 1 into Qn bar. Here the 1 will come for that one. Here the 0 will come for that one. In this expression can be expressed for that one Qn bar equals to 1 bar plus Qn bar equals to Qn will come. Qn will come for that one. Qn plus 1 whole bar equals to 0 into Qn bar. Qn bar. Yes. Next is a 1 will come for that one. 1 will come for that one. This is a Qn equals to 0. Qn equals to 0, it is a reset. Qn equals to 0, it is a reset. Yes. Next I am going to explain about the J equals to 1 and K equals to 1. A simple thing can be expressed. It is in the reset. Next condition can be expressed it in j equals to 1, k equals to 0. Qn plus 1 equals to, it is a 1, it is a 0. It is a 0 comes here, 1 comes here. Qn plus 1 equals to 0 into Qn bar whole bar equals to 1 will come, equals to 1 will come. Qn plus 1 whole bar equals to 1 into Qn. It is a 0 Qn bar. It is a always a, it is a Qn bar equals to 0. The Qn equals to 1. It is a set. It is a set. Right. Next I am going to express about this one in this equation. Both are in the high. Both j and k are in the high. Yes, both j and k are in the high. What will come for that one? Let us see that one. Yes, let us see that. J equals to 1 and k equals to 1. J equals to 1 and k equals to 1 can be take it. Qn plus 1 equals to 1 it comes, it is a 0 will come, 0. Both the 0 will come for a fourth equation for that one, equals to 0 into Qn bar whole bar equals to 1 will come. Qn plus 1 whole bar equals to Qn bar will come. That time this state can be called it as a toggle. Toggle, it is a very important state in the JK flip-flop. There is a main difference between the JK flip-flop and the SR flip-flop. This is a toggle. It is a fourth state can be condition of the very deserved special attention for that one. Applied to its input. Previous state it is a set and next state can be expressed. This toggle means switch to opposite state. Switch to opposite state means 0 it is there, it is a 1 will come. 1 it is a there, it is a there, it is a 0 will come. The flip-flop will continuously change its state during the clock pulses. This is an unstable form of the operation in the oscillation. In the oscillation it is an unstable state. That is the main difference between the SR flip-flop and the JK flip-flop is this is the main difference of that one. Yes, in the propagation of that when the positive going edge can be expressed in the graphical representation of this one. I am going to express the graphical representation. Correct. A graphical representation of the JK flip-flop. It is a first one I am going to express in the J. J is first low, high, low, high. It is a one cycle. Next it is in the K. K it is a low, it is in the high state. Then it is a low, then it is a high. This is a J and it is a K. Next, clock pulses are continuous and the Q is, it is in the high for one pulse, then it is a constant, then it is a low. This is the way to represent the, this is a clock, this is the circuit of the JK flip-flop, of that graphical representation of the JK flip-flop. Let us see that. When the JK flip-flop is a positive edge trigger JK flip-flops, the basic circuit is identical to the previous positive edge triggered RS flip-flop. with two important additions. Triggered RS flip flop with the two important addition, the of that one, Q output connected back to the inputs. It is a feedback, like a feedback. The lower AND gates and the output is connected to the input of the upper AND gates. This cross coupling from the outputs inputs RS flip flop and JK flip flop previous S is known as a labeled J, and the previous R input is the labeled K. K means previous R can be called it as a K, previous S can be called it as a J. Yes, this is the way to express how it works when the J and K are both are low, both and gates are disabled. Therefore, the clock pulses have no effect. It is a no change effect. Yes, this is the main function of that one. Edge triggered JK flip flop can be expressed when the J is low, K is high, the upper gate is disabled, so there is no way to set the flip flop. The only possibility of this flip flop, the only possibility is reset. When the Q is high, the lower gates are passes reset pulse. As soon as the next positive cycle ends, arrive the force Q to become the low. When the J is high and the K is low, is a lower gate disabled. So it is a possible of the reset flip flop. When the Q is low, is a high. Therefore, the upper gate is passes a set pulse when the next positive clock edge. When the J and K both are in the high possible reset flip flop, Q is high, lower gate passes a reset pulse. Next state either can be used Q bar in the passes that set pulses. Either way of Q changes, it is a toggle will come. The toggle means it is a inverse for that one in the opposite action for the inputs. J and K are high, flip flop will be toggle, switch to opposite state. On the next position of the clock edge will come. This is the basic symbol of the JK. It is a clock. It is a 74LS 768 is IC numbers of that one. Edge triggered JK flip flop. A toggle flip flop is popularly known as a T flip flop. That is a one more flip flop rise from the JK flip flop. That is a toggle flip flop. Yes, this is the toggle flip flops can be used in this popularly known as a T flip flop. Has the following inputs relationship can be see that one. When the T is equals to, like a SR flip flop has a D flip flop, JK flip flop has a T flip flops. That is a combination of that. That is a combination of that one. When the input T equals to 0, the output Q does not change its state. For T equals to 1, the output Q toggles its value. For JK flip flop inputs J equals to K equals to 0. And the Qn plus 1 equals to, can be see that one. T equals to 0. I'm just to draw the K map for that one. A T and Qn will call 0 and 0 1 can be expressed in this value for that one. Both are zeros. Qn plus 1 is a 0. Both are 0 1, it is a 1. 1 0, it is a 1. And this is a 0. Can we call it as this one is a what? A bar B or T into Qn. Yes, this is the way to express Qn plus 1 can be take it. Yes, that is the use of this T bar Qn plus 1 plus Qn plus 1 bar T. That is the main use of that. Resulting the circuit will behave as a flip-flop. Flip-flops timings can be used at one. The propagation delay can be studied about this one. This is not in for your syllabus. Next is a JK and JK master slave flip-flop. JK master slave flip-flop means that one. First, I'm going to explain about this normal JK flip flop and D flip flop can be edge triggered. You have studied. I'm going to just express the normal JK flip flop. You have studied about this one. Yes, I'm going to express the circuit of the edge triggered JK flip flop. I'm going to express the edge triggered JK flip flop circuit is this is a edge triggered JK flip flop. Qn Qn bar. This output to this one, this output to here, and then J and K. Yes, one more wire can be take it. It is a clock. This is the NAND and the a NAND gate using the clock pulses. It is like that in this JK flip flop. In this, it is a edge triggered JK flip flop. Yes, if can we give the 0 0 that one, can we get it 1 1 here, then can we changes for this circuit will output will no change will come. Otherwise 1 0 can we give 0 0 1 can be give 0 1 can be give 1 and the 0 will come. Next is a reset. Otherwise can we give 1 and 0. 1 and 0 can be give that one. This is a 0 and this is a 1 will come. That is a set. Then last but not the least, both are 1 1. It is a 0 0 will come. That is a toggle. The Q bar will come for that one. This is the circuit of the edge triggered JK flip flop. Yes, and next I'm going to explain about the JK master and slave flip flop. What is the master and what is the slave means? Two JK flip flops are joining each other. One is a master and the second class is a means that one second one is a slave. Here it is a two flip flops are there. This is a master. This is the slave. This is the slave, this is the master. Two JK flip-flops are added by the using this not gate. Using this here in the not gate can be used here. That can be call it as a master slave flip-flop. That can be call it as a if you are giving the clock, that is a not of that clock. If the clock is high, here the clock is 0. Here the clock is 0, here the high. That can be used in this circuit can be expressed. Yes, the second class of the flip-flop in the plus triggered master is terms of the pulse trigger means that data enter into the data is the data is enter into this clock. they enter into this clock pulse, the output does not reflect on the input state. This this output is not reflect on input. The output is not reflect on the input. That is the main function of the master and slave flip flop. These are the very important role of the master and the slave flip flop. Master slave flip flop constructed from the two parallel flip flop, two separate flip flops. I am going to express here a circuit is there or not. I'm going to just this is the circuit. Using the NAND gate, it is the inverse of the clock can be used. Inverse of the clock can be used here in this equations. Huh. Can be expressed it in this output can be explained briefly. Master slave flip flop constructed from the two separate flip flops, JK flip flops. First circuit is a serves as a master. Here it is a master. This is a master, this is the slave. Yes, these are the slave and the master flip flop. There are three basic types of pulses triggers: RS, D, and JK, by the most commonly available IC from the here. Master slave RS flip flop can be master slave JK flip flop can be expressed in this one. The master slave were constructed by the NAND gate. Using the NAND gate, by using the NAND gate, I'm going to express this one. Yes. First, I'm going to express about the both the here the Q1. Yes, Q bar will come. Q is come here. Then Q will come here and Q bar will come here. Yes. First condition of that one, j equals to 0 and the k equals to 0. This is the first condition. Then the output is qn plus 1 or qn. Both are same, but it is a qn bar qn. Here. Next I am going to express this circuit for that one. I am first taking the j equals to 0 and the k inputs are zeros. Yes, let us check this circuit. Now let us take the 1 and zeros here, j equals to 0 and k equals to 0. Next I am going to express about this condition 0 and 0. This is the clock is high. If it is a 1, 1, that will come in the q bar for that one in this equations. The what is the comes in this place, it is a clock is 0. The clock is 0, then the qn plus 1 equals to, I am going to expressed in the present state can be expressed in the x 0 1 0 1 can be used. J equals to 0 and k equals to 0 can be expressed by the k map, can be expressed. The k map can be expressed. Yes, qn plus 1 here. This is the 0 0 and 1 1 will sorry 0 0 will come, 0 1 0 1 will come, that one. In this one, this is equals to qn plus 1 will come. This is the executed. Then next one is a qn can be expressed this j equals to 0 and k equals to 1 can be expressed qn equals to qn plus 1 equals to 0 into qn bar whole bar. This is a 0, this is a 1 will come for that one. Yes, that time 1 bar is a 1 into qn. It is a qn will come for that one in the output. Next is a reset. Reset will come for that one. J equals to 1, k equals to 0. 0 will come and 1 will come equals to 1 and the 0. Sorry, here the 1 and 0 will come. Yes, this is the way equals to qn plus 1 equals to 1 into qn bar whole bar equals to, it is a qn. Qn plus 1 whole bar equals to 0 into qn. It is a 1 will come for that one. Qn equals to 0. The condition is reset. The condition is reset. The condition of that one can be expressed in j equals to 1, k equals to 1. Then the k equals to 1. The both the conditions are in the 0 and 1 comes here. It is in the clock is high for that one, can be expressed qn plus 1 equals to 0 into qn bar whole bar equals to 1. Qn plus 1 whole bar equals to 1 into qn, that is a 0 will come. That is a 1 is qn equals to qn plus 1 equals to 1. That comes here. It is a set condition. Yes, these are the JK master slave flip flop. Next, JK master slave flip flop, I'm going to explain about this is, to begin with, the master is a positive level triggered and the slave is a negative level triggered. Why? It is in the positive, one clock will give that here, one clock will come here. It is a inverting of that one. It is a 0 will comes for that. J equals to 1 and k equals to 0. Master is on the positive clock transitions. Then it is a first cycle. No change, reset, set, toggle. This is the first set of that one. J equals to 0, k equals to 0. In the next, qn plus 1 equals to qn l h qn bar will come for that one. This is the next state of that one. Yes, condition to compare between these two. Low it is a qn, low high it is a reset 0. HL is a set, HH is a toggle. Master's JK inputs are both are high, toggle on the positive transition of that one. Master JK flip flop, the truth table reveals the action means that the pulse symbol. Yes, the second symbol it is up. This is the first symbol. Second symbol appearing in the next to the Q and the Q bar output is in the IEEE designation for the postponed output. In the case of means, Q does not change state until the clock makes an negative transition. In other words, the contents of the master are shifting into the slave. The clock is in the negative transitions. This time Q changes the state. To summarize, the master is set according to the JK while the clock is high. The content of the master shifted into the slave queue. The flip-flop might be referred to as the pulse triggered distinguish. The JK master flip-flop, this is the clock and this is the Q output for that one. Both the clock high to low, low to high, it is in the positive transition, it is in the high. Low to high, it is in the negative transition of the JK flip-flop of the slave. This is the master. This is the master. This is a slave. Slave is a negative transition and the master is a positive transition. Right? we are going to express this is the circuit of the JK using the AND gate. Okay, these are the JK flip-flops. Okay, thank you. Please watch our videos regularly. Thank you.